Hi everyone, we the team JEE Gnan are here to help the students who are required to get into the great colleges or universities like IITs, NITs, IIITs, GFTIs or other universities to make their dreams come true. We make your concepts clear and help you to solve the problems from different subjects, topics, subtopics, etc., which really helps. Talking about me, I am Jyothish and I am pursuing my B.Tech at IIITDM kancheepuram. I am from Computer Science Department and today I am here to explain some of the beautiful problems related to the topic 3D geometry. Talking about 3D geometry, it makes you to think out of the box, which is useful for you. And talking about its weightage, almost 2 to 3 questions are asked in JEE Mains and Advanced every year. So if you learn 3D geometry perfectly, you would definitely solve all the problems in the exam and it makes you score better. And let us start now. The given problem is we need to find the distance of the point 1, minus 5, 9 from the plane x minus 5 plus z equal to 5 measured along the line x equal to y equal to z. So let us consider a plane which is x minus y plus z equal to 5 and then let this be the point 1, minus 5, 9 and this be the line x equal to y equal to z. So now we need to find the distance from this point to the plane measured along this line. So this is the plane. So if we just this is the distance we need to find. Let it be the distance d. Now and this line have the direction ratios as 1, 1, 1 and it is passing through origin 0, 0, 0. Now let this be that we need to find this line equation. So that will be it is passing through the given point 1, minus 5, 9 and it is parallel to this line with the direction ratios 1, 1, 1. So the line passing through A with direction ratios 1, 1, 1 is x minus 1 by 1 equal to y minus of minus 5 by 1 equal to z minus of y equal. This is the line equation passing through A parallel to this and it touches the plane at let it be B point. So and let this be lambda. So any point on this line will be x equal to lambda plus 1, y equal to lambda minus y, z equal to lambda plus 9. So this is the any point on this line. So it touches the given plane at B. So that it means this point must lie on the plane. So substitute this in the given equation of plane. So x minus y plus z equal 0 and x is lambda plus 1 minus y is lambda minus y plus z lambda plus 9 equal to 5 and then lambda minus lambda here gets cancelled and this lambda 1 plus 5 plus 9 it will be 6 plus 9 15 equal to 5 lambda will be minus 10. Substitute in this given we'll get the point x equal to lambda plus 1 so minus 9 y equal to lambda minus 5 so minus 10 minus 5 minus 15 and z equal to lambda plus 9 minus 10 plus 9 minus 1. So this is the point B and we need the distance from A to the B. So distance between 2 points we know root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So distance AB is root of x2 minus we know the given point is 1 minus 5 9 and the B is this is A. So minus 9 minus 1 minus 10 whole square minus 15 plus 5 it will be minus 10 whole square again plus minus 1 minus again minus 10 whole square. So this will be root 300 which is 10 root 3. So the distance measured from A to the plane along the line x equal to y equal to z is 10 root 3, and this is how you solve this problem. It's actually a pretty simple question. We need to think to get to the answer, that's it. And the given problem is we need to find the angle between the lines whose DCs satisfy these equations. So now we need to solve this equation. So here L is equal to minus m plus minus n. So squaring on both sides we'll get L square equal to m square plus n square plus 2mn. But we know that L square equal to m square plus n square will get cancelled on each side. So mn is equal to 0. Now our first case, if m is equal to 0, then we know that L plus m plus n equal to 0. M is 0, L is equal to minus L. So L by 1 is equal to m by 0 is equal to n by minus 1. It represents the equation of first line. Or if n is equal to 0, then n is equal to minus m. Then L by 1 is equal to m by minus 1 is equal to n by 0. This represents the second line and this is the first line. So we have the direction ratios of first line, second line, and now we need to find the angle between the two lines with the given DCs. And we know the formula with given direction ratios a1 b1 c1 a2 b2 0. The angle between them is cos theta is equal to a1 a2 plus b1 b2. So if we do it, 1 plus 0 plus 0 by root 2 into root 2. So 1 by 2. So cos theta. So theta must be pi by 3, 60 degrees. This is the angle between those lines. The given question is we need to find the image of this line with respect to this plane. So let this be the given plane. So let this be the given line. So we need to find the equation of this line. Means it must be the image with respect to this plane. So it is passing through 1, 3, 4 with direction ratios 3, 1, minus 5. So this line is also parallel to this line. So it has the same direction ratios. So we need to find a point so that we can get the equation of line. How? We have this point in this line. So image of this point will lie on this line. So we need to find image of this with respect to the plane. We know the formula. Equation of image of point with respect to plane is, this is the formula. So when we substitute h comma 1 by 2 is equal to y k minus, it is passing through 1 3 4, right? So 1 3 4, and the direction ratios of the normal of the plane is 2 minus 1 1, and this if we substitute we'll get 2 into 1 minus 3 plus 4 plus 3 by a square plus b square plus c square 6, and this is minus 2, and we'll get h is equal to minus 4 plus 1 minus 3, and k is equal to 2 plus 3 5, I is equal to minus 2 plus 4, it must be 2. So now we got the point and with direction ratios 3, 1, minus 5. So equation of the image of the given line is passing through this point with direction ratios this, and we know we can write that passing through that point, and this is the equation of image of line with respect to that point. And the given problem is this line lies on this plane, so we need to find alpha comma beta. Now if this is a plane, its ds are actually nothing but the ds of its normal. So this line lies on this plane, so it passes through 2, 1, minus 2. That it means it must also pass through this plane. So substitute that point in this plane. So 2 plus 3 into 1 minus alpha into minus 2 plus beta equal to 0. It gives 5 plus 2 alpha plus beta equal to 0. And now here the line ds and the equation of plane ds are perpendicular to each other. So the condition is a1 a2 plus b1 b2 plus c1 c2 is equal to 0, and the ds of the line 3 minus 5 2, ds of the plane 1 3 minus alpha. So 3 into 1 plus 3 into minus 5 plus minus alpha into 2 is equal to 0. 3 minus 15 minus 12 plus 12, and alpha is plus 7. No, minus 6. 3 minus minus 12, and that side plus 12 and minus 6. So here substitute in this equation of 5 minus 12 minus 7. So that side it goes, beta is 7. So alpha is minus 6, beta is 7. So that's the concept in this problem. And the given question is, ABC is a triangle with vertices A, B, C in 3D space. If the median through A is equally inclined with axis, then we must find lambda, mu. So let this be a triangle with ABC vertices. So median through A is equally inclined with axis. So, and we need to find first centroid of the triangle because it lies on the median through A. So centroid is nothing but sum of the x values, sum of the y values, sum of the z values by 3 is the centroid of the triangle. So centroid is equal to x1 plus x2 plus x3 by 3. So 2 minus 1 1 plus lambda by 3, comma 3 plus 3 plus 3 5 11 by 3. 5 plus 2 plus mu is 7 plus mu by 3. This is the centroid. So we have G, AG. So it is equally inclined with axis. So their drs must be equal to each other. So dr of AG, direction ratios of AG line, means which is nothing but median line through A. 1 plus lambda by 3 minus 2 comma 11 by 3 minus 3 comma 7 plus mu by 3 minus 5. We know direction ratios of 2 points is x2 minus x1, y2 minus y1, z2 minus z1, but it is equally inclined with the axis. So these three must be equal to each other. So first evaluating first two terms, 1 plus lambda by 3 is equal to 11 by 3 minus 1. 1 plus lambda is equal to 8 and lambda is equal to 7. Evaluating last two terms, 7 plus mu by 3 is equal to 11 by 3 plus 2. 7 plus mu is equal to 17 and mu is equal to 10. So lambda is 7, mu is 10, and this is the concept in this problem. And the given problem is we need to find the distance between two parallel planes given here. We know the formula. Distance between two parallel planes is d2 minus d1 or d1 minus d2 mod by root of a square plus b square plus c square. ABC are the drs of the given two planes. They must be equal. But here they are proportional but not equal. So we'll multiply first equation into 2 times. So it will become 4x plus 2y plus 4z equal to 16. And the second equation 4x plus 2y plus 4z equal to minus 5. Now they look similar. So now we have d1, d2 and the ds 4 to 4. And substituting in this d1 minus d2, we'll get by root of a square plus 4 to 4. So 16 plus 4 plus 16. we'll get 21 by root 36 is nothing but 6. This is 3 7 jar 2 jar 7 by 2 is the distance between the given two parallel planes. And the given question is, if the angle theta between the line and the plane is sin theta is equal to 1 by 3, then we need to find this lambda. So let me clear you a concept. So we know that angle between two lines is cos theta equal to a1 a2 plus b1 b2 plus c1 c2 by root of a1 square b1 square c1 square plus into root of a2 square plus b2 square plus c2 square. But when it comes to a plane, so if the angle between line and plane is theta, so the ds of plane is nothing but the ds of its normal. So here, if this is theta, this becomes 90 minus theta. So we know the ds of the plane, which is nothing but ds of this normal, and the ds of line. Then if we apply the same formula, cos 90 minus theta is nothing but a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into a2 square plus b2 square plus c2 square. It will become sin theta. Cos 90 minus theta is 9 theta, and the remaining as usual formula. Now they have given sin theta is 1 by 3. So 1 by 3 is equal to, and the ds of the plane are 2 minus 1 root lambda, ds of the line are 1 2 2. So a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square. 4 plus 1 5, 5 plus lambda root of 9. So this will get cancelled, this one, and we'll get root 5 plus lambda is equal to 2 minus 2 2, it will get cancelled, 2 root lambda. So 5 plus lambda is equal to 4 lambda. 3 lambda is equal to 5. Lambda is nothing but 5 by 3. So this is the concept in this problem, and it is very easy. Given two lines are coplanar and we need to find the lambda, we know that if two lines are coplanar with one line passing through x1 y1 z1 a1 b1 c1 direction ratios, and second line passing through x2 y2 z2 and with direction ratios a2 b2 c2, then this det must be equal to 0. And the given problem is we need to find the points and direction ratios. So the first one, x minus 1 by 1 is equal to s, comma y plus 3 by minus lambda is equal to s, z minus 1 by lambda is equal to s. And the second equation, x minus 0 by 1 is equal to t by 2, y minus 1 by 2 equal to t by 2, z minus 2 by minus 2 is equal to minus t by 2. And now we have the points and direction ratios of the given lines. Now just substitute in this, and x2 minus x1, so that is means 0 minus 1 minus 1, 1 minus of minus 3 4, 2 minus 1 1, and 1 minus lambda 1 2 minus 2 must be 0. So minus 1 into 2 lambda minus 2 lambda, this is 0, minus 4 into minus 2 minus lambda plus 1 into 2 plus lambda, it must be 0. So this is minus 8 plus 4 lambda plus 2 plus lambda must be 0. And then 5 lambda is equal to 6, and lambda is equal to 6 by 5. I'm sorry, this is plus 8, so 8 plus 2 must be 10. So 5 lambda is equal to minus 10 and lambda is equal to minus 2. And now So like these problems, there are many problems. Like one of the problem is they'll give 2 points for you, and they'll ask the projection of this 2 points on a plane. So what you need to do, you need to find the length of this, and then you need to find the angle between the plane and the line. So then length AB cos theta is the projection on the plane, which is the distance you needed. So that is this. A dash B dash is nothing but AB cos theta. And you got coplanar problem. Yes, these problems are simple if you just use the logic and the formulas. As I told, 3D geometry makes you simple if we think out of the box. And I'm suggesting you two rules. Rule number 1, rule number 2. So, rule number 1. So, to succeed as a JEE aspirant, you need to practice more and more. So, practice makes a man perfect. You know that, right? So, more the number of problems you practice, you will succeed more. And rule number 2, never forget rule number 1. And thank you, and follow our JEE Gnan for more videos, for making your concepts clear, for solving any problems if you're not getting them. And finally, thank you. Subscribe to JEE Gnan.